Dr. Atchison here, and we're talking about Chapter 6, Perceiving Depth. This is our first lecture, the overview and oculomotor cues. So the whole problem with depth perception is that we live in a 3D world, but our eye, our retina, processes everything based on a 2D retinal image, okay? And so the process of depth perception is this disconnect between what we see and what the retinal image actually is. And we get one retinal image in each eye. And because of those two separate 2D representations, we're able to depict depth visually. So here's a video that kind of walks you through some of the illusions based. So as you saw there, all of these are tricks on your depth cues. So we'll talk about the different depth cues that are involved. In our perception of depth, we have monocular cues, we have oculomotor cues, and we have binocular cues. And illusions like this really take all of those together, the understanding of all of those together, and play it against us and trick us so that looks like a roof of a house, when really it is the reverse and it's more concave than convex. Okay. So again, the issue that we have in our visual processing is that we have a 3D space with 2D representation. And the issue with that is when you have 2D representation, we can have a whole bunch of different 3D scenarios that involve the exact same retinal image. So here we have two different balloons at two different distances. So the first image A, the balloons are the same size and the balloons are the same distance. That creates a retinal image where they're equal sized. In image B, however, the red balloon is a lot smaller than the purple balloon, but it's a lot closer. So that also creates the same retinal image. And this is where that many-to-one problem is. There's an infinite variety of 3D scenes that can produce the exact same retinal image. So then how do we get depth? What are we doing to get depth in the first place then? Another example of this is here. This woman has the exact same retinal image for each of these three objects. They're different shapes and they're different depths. And all of these things produce the exact same square retinal image from these different shapes and these different spaces. So the issue is how are we able to make sense of this? And again, there are three different main kinds of cues that we do this. The first of which we're going to talk about in this video, the oculomotor cues. And then all the cues that are based on these variations in retinal image, the monocular cues and the binocular cues, we'll talk about in subsequent lectures. So the oculomotor cues are really information that's sent to the brain about what the eye muscles are doing. So how the eye muscles are moving for convergence, how the eye muscles are moving for accommodation. Monocular cues are all these cues that we get from just one retinal image. And we're actually going to spend the most time talking about that because, as you can see, there is a ton of them. We have both static and dynamic cues there, and there's different types that we'll discuss. And finally, we'll sum up with binocular cues, and this is that information that's obtained from both retinal images together. Okay, so this is where we'll start talking about putting the two eyes back together into the visual depth stream. And then we'll finally wrap up this lecture series talking about how we put that image back together. We're going to look at constant kinds of perceptual constancy. We're going to talk about integrating these depth cues. And then we'll end up back where we started with some illusions that play on these depth cues. Okay, so the first ones we're talking about again are these ocular motor depth cues. And again, we need depth perception for basically everything we do. Whether we're going somewhere, whether we're getting something, whether we're throwing, catching, reaching, grasping, pretty much everything we do, or the majority of everything we do, depth is an important perceptual information. Again, the ocular motor cues include accommodation, which we talked about in chapter 2, and that's, again, that changing of the lens shape, right? So whether it was, flat or whether it was rounder, again, this accommodation, that information about how we're adjusting our lens is information that's sent to the brain that helps us understand depth. And this and convergence are the only effective ways, really short depth. So if something's really far away, like if it's 20 feet away, accommodation and convergence aren't going to do us good. These ocular motor depth cues are only helpful at about 6 feet away or less. So here's some examples of that. Convergence is, again, how we move our eyes together to really continue to main focus, to continue to fovate, or how we move our eyes apart to maintain objects that are further away. So again, in this first image, A, your eyes must converge at an object that's really very close, about 10 centimeters away. And you can feel your eye muscles working to form that angle. So if you hold a pen up to your face really, really close, you can feel those eye muscles straining to try and both look at that same thing. Basically, your eyes are almost crossed if you're holding something that close to your face. The second one, in image B, is 1 meter away, so that's further away, and that's going to be a much more comfortable relaxation for your eyes. You're not going to necessarily feel it as much, so you're not going to have that feedback. It's going to be as noticeable. And when things are even further away, say 6 feet away, again, it's going to be even less hard. You're going to have to use those convergence muscles even less to really focus on something that's much further away. So again, that feedback is something that we use to determine depth. The more feedback we're getting from our eyes and how close we're having to kind of converge them gives us information about how close or how far something is. So that ends our lecture of the overview and ocular motor cues for depth perception. Thanks.